Hey guys, welcome back to the channel. We're in the RV again, the 2018 Thor Ace that we bought used a year ago, a little less than a year ago. Today I'm going to install this transfer switch, I think also called the changeover switch, because behind me we have a residential refrigerator. And this residential refrigerator obviously runs off of generator or shore power, 110 volt typically. But there is a power inverter. We do have a power inverter, and here's the switch for the power inverter. But as you can see, it is a well-worn switch, so it appears that it's been used a bit. And the history of this RV is that we bought the RV, found out on our drive home that the RV was a former rental RV. So clearly they've used the switch. But one thing with these Thors that I'm not 100% sure about is if these residential refrigerators were just completely run off of this these inverters. So we do have a pure sine wave 1000 watt inverter, and it is right here underneath the refrigerator. So clearly is an easy way to plug the refrigerator in. I've already removed the drawer, so there's a drawer. But the problem is, I mean, obviously it's pretty dusty and dirty down here, but the only input or output, I'm sorry, for this inverter is it's hard to see, I'll try to get you in there. It's just the outlet there, the 110 outlet. There aren't other wires to run it back to the panel, so I can, we can power, whatever this 1000 watts will power, the handful of things, the lights and a couple of plugs. But what you can see here is an outlet that was wired in. I don't know if it's from the factory. It's hard. I'm not 100% familiar with these. Sometimes they call them cheap factory or cheap outlets that they make for RVs. But it's just wired in to plug into this outlet here. So it would make sense that you could plug it into this inverter. But the problem, I guess, would be that if it's always plugged into this inverter, it would be plugged in all the time. You'd have to have the inverter running even when you're plugged into shore power, which you can do, but that's a lot of stress on your inverter. I only want the inverter to run the refrigerator when we're driving down the road. Obviously, in the summertime, we do have the generator on, an hour or two into the trip to run the AC in the back, which would turn the refrigerator on. But in the wintertime, we don't need to do that. So there's no need to run the generator, so we can drive 5 or 6 hours when it's cooler out without turning the AC on, and the generator or the inverter would be the only thing that would power the refrigerator if it's even on. It'd be awesome to put a 12 volt refrigerator in here, but just don't have the money for that now, and this one's running perfectly fine, so there's no need to spend the cash to change out this refrigerator. So it's on right now and it's working. It's a good working refrigerator. We like it. But the last time we traveled, I unplugged it and then plugged it into the inverter, and then I take this drawer out again, take everything out of the drawer, and then unplug it and plug it back in, and it's just kind of annoying to do that. So I am going to run this inverter switch. Now I'll probably cut to me wiring the switch here in a second, but what I've done is I've wired these plugs to it. So right now the power is on in the RV, the generator is running, so I've got some I had the ACs running, but I turned them off for the sound. But the generator is running and this refrigerator is running. I'm going to be able to wire this switch up and plug this refrigerator in without even cutting the power, and that's what I've designed here. This is also really easy to remove in case you want to go back to whatever setting or however this thing was designed before. So I'll show you how I wired this switch, which is pretty interesting. I've also got a wiring diagram, and I'll try to pop that wiring diagram up. It's a really simple wiring diagram that kind of shows how I bridged the connections, or which connections are bridged also when it's in its specific setting, and how I ran the jumpers and how that is. So with that diagram, maybe you could pause it and look at the diagram. Hopefully that'll help you a little bit. But also I'm going to take you step by step through how I wired this with these cables. There were two different cables I bought, and hopefully that will show you how you can walk through step by step with this 2 input 2 output changeover switch that I'm about to install. Okay, here is the changeover switch. Hopefully you can read that. 440 volts, 20 amps, 28 by 22. So it's a APIELE 3-position latching changeover switch. I don't know if you have the part number. I'll try to remember to link it. Hopefully I do. But here's the switch itself. It's got 2 settings. Obviously 1, 2, 0. I kind of went over this thing just to make sure, and I think I saw some others, but I really didn't see other people kind of get into the depths of how to actually wire this, because it can be slightly confusing. But I did see others, ohm it out and do the continuity test to see which terminals connect. And obviously with it in the off position, so right now it's in the off position, there are no terminals that work. But when it's in the number 1 position, so it's on number 1, what I found is the top terminals that are across from each other on top will have continuity. But side to side, or top to bottom, they will not have continuity. And then when you switch it to 2, the bottom have continuity. And again, if you're back to 1, they do not have continuity. So I'm counting the top as obviously 0. So when you're at 0, this will be 0. So what I'm going to do is actually jump these 2. But I need to make my jumper first, and then I need to make my leads. So the first thing I'm going to do to wire this is jump one side of the top to the bottom. So this is going to give me my leads, and I'm going to do that with some simple Romex, just the white and the black wire. Then obviously, whichever one of these I put the black jumper to, and then the white, that's going to correspond to white and black on all the rest. So I'm just loosening these so they'll fit. I'm going to measure out my jumpers. And on the top is also where I'm going to put so I'm going to put it on it's hard to see here, but I can actually insert this wire into one of 2 places behind this screw. So now I'm going to measure my jumper, and I'll strip all 4 wires here. Go ahead and tighten it down. This is where I'll come back later and put in the other wire that I'll show you here in a second. And that'll be the wire that goes to power the refrigerator. All right. So this one's in. And I'll do the same thing with the black wire. So just to show what I did with these, I wired the black and the white wire to the back and the front of these connectors, just so I can move them out of the way and actually get to the screws, because if they're over the top or kind of interfering with each other, they're good. But again, this is the top, number 1, and I'll use these again, but I won't touch these after. So now I'm going to prep up the plugs. So as you saw underneath that, in the drawer, in the area where I'm going to put these, there's a plug, and that plug is going to come down, and I'm going to use the plug so I don't interfere, like I said before, with kind of the wiring that's there. So really I just need this plug, and all I bought, these are 2 8-foot extension cords, 16 gauge extension cords. And I'm going to use them, so I only need really 2.5 of these. So the first one, I'm going to need the male end that's going to go into that plug, and then this wire is going to be, this end is going to be wired into the switch. think I'll leave a little more on the ground side. And then just enough. So now I have to make a decision. Do I want number 1 to be the power, number 2 to be the inverter? I think since driving down the road, not running power is kind of the second option, I think number 2 is going to be the inverter. So knowing that these connect when it's on 1, I'm going to run the top, which is the number 1. I'm going to connect those to the wire that is going to be plugged into 110 volt. So these are pretty simple connections. I think they'll be really easy. This isn't, isn't a lot of voltage, a lot of power that this thing is running. So, all right. So now, obviously, this is top again. White in front, black in the back. So neutral and hot. Obviously, neutral and hot. So hot in front, neutral in the back. So just lining up white to white wires. This is going to be, and if I need to make a longer ground, I will. So this is going to plug into the outlet that's under that refrigerator. And then this is going to power, when we power on to number 1, we're going to have power out. So now I'll hook up the other one, the other male plug that looks like this. I'll make one more of these, and that's what's going to run to the inverter. This one I'm going to make much shorter because I do not need that much cable to get to that inverter. So now I'm going to do the same, obviously here on the bottom. Black to black, white to white. So now we have the plug that'll be plugged into the inverter running into the bottom set of switches, and then the plug that'll be plugged into house power running into the top. Now I just need to make the plug that the refrigerator is going to plug into, and I think that can be shorter as well, so I'll cut this one down and run that into the top of the jumpers. So I'm going to back these 2 screws off on the top here. So when you're tightening down the output in line with the Romex, so if you wanted to run this stranded wire, it might be easier if all you're going to use is stranded wire, but I think I'm going to stick with the Romex. I like that. It's good to double up this wire. So here I've doubled up these. So I cut the wires about twice as long as I need them, and I doubled them up because when you put them back in here, you want it to actually bite down and hold this braided wire where the Romex is solid, and it may not give you a chance to actually bite down and hold this wire in place. So once you got these in there, you want to go through and give every wire a tug, even if you got to use your pliers, and make sure they're not going to come out of there. And the wire nut is simply going to be for my ground. All right, so hopefully I can go over this so that everyone understands it. Again, in the neutral position, when there's no power supplied to anything, there's no continuity across any of the terminals, it's off. So the top terminals connect across to each other, and nothing top to bottom connects to each other. So you're only getting basically 2 wires connecting each time. So without using these bottom 2 wires, you need to run jumpers from the top to the bottom. So the jumpers are either going to come powered from here, or they're either going to be powered across the top, or they're going to be powered across the bottom. Remember, when it's in a different position, there's not going to be a connection. So if you're in the number 1 position and you're wired across the top, it's going to provide power and close the connection of both wires across the top, and then send that out from this top wire to the output, which is where the refrigerator is going to be plugged into. But it's not going to send, obviously it's energizing these, but I'll show you that it's not. So here is my, so across the bottom, it is not closing the circuit across the bottom. So it is not going to close the circuit. It's not going to backfeed the power in the RV. So that is what is important. I suppose you could have gotten the switch with the third set of terminals to wire in all of the grounds, but it's just ground. So you can twist the grounds together. You shouldn't have a problem. I don't think these are going to affect anything in any way. Again, this is a 20 amps. You know, we're looking at, you know, much less than 20 amps to run that refrigerator, so we should be all set and good to go. So again, the transfer or the inverter switch is here next to the control panel, but I'm going to run my transfer switch. I brought the light down here, right down here where, you know, right inside the door where the main power control is, the awning control, some of the step controls in the awning switch. There's a little storage compartment. So I'm going to put the switch right here inside of this storage compartment. I think it's going to be pretty simple to do. It's all I'm going to need is, besides a screwdriver, is my drill with a drill bit. I think a 1/4 inch drill bit would be perfect. But this is 5/16 because my quarter is broken, so, and missing, so I need another one. But this one should do just fine. It's a little bit larger. We should give us some room to go ahead and install this. So the first thing I'm going to need to do is drill my center hole for the center of the switch. So I'm going to do that right now. Once that center hole is drilled, I just need to take the switch itself apart. It's pretty simple. There's just a screw in the center of the toggle switch here. And once I take the screw out with the smaller bit, it's pretty easy to take apart here. Then you've got the switch taken apart. So now I know that my output is on the right and my jumpers are on the right. So then this is going to be up. So first thing I'm going to do is quickly mark these holes, drill those holes as well, and then we will slide this in and put those screws in, put it together. It should be pretty simple. So now that I've got those holes drilled, I'm going to feed this in right here from the back, and then I'm going to put these screws in from the other side. All right, so I've got these nuts installed. One tip, these screws are installed, these little bolts. The nuts on the back of these bolts, they don't stay in. There's inserts on the other side of the switch. They don't stay in very well. They fell out a couple times, so I did have to struggle a little bit with these as the screws fell out. But if you can get, this here is a tight spot. You know, if you're working somewhere tight as well, hopefully you can reach back behind this panel like I was able to, and actually hold down the hold those nuts in the back or get them in if they came out. So yeah, this little cover plate here just snaps on. There's both sides have a little just a little catch for them. I just had to push hard. Didn't seem like it wanted to go, but yeah, it went. So make sure, yep, we're in the right direction. So one is shore power, and then two is going to be inverter power, both 110, 120. All right, hopefully this is the best angle I got. Again, my goal here was to keep this simple with these plugs. So for number two, I'm just going to go underneath. All right, so that one's plugged in. So now I have the top one, which is number one. Number one is going to be the shore power. So I'm going to run that under here as well. Down here, I'm going to unplug the refrigerator. Now this is going to plug into this single outlet. Now the refrigerator is here. I think I can run the plug output down, and then I'm going to run the output down and underneath these wires also. And now I'm going to plug in the refrigerator. Brought a bunch of zip ties, but I think we're good. That's all out of the way. These guys are out of the way. I don't think that's going to be a problem. Okay, it's time to test her out. The switch is in the neutral position, so we should not have, and we do not have any power going to the refrigerator. Switching it to 1 should give us power in the fridge. And it does, awesome. So now I'm gonna switch it to 2. Now we're switched to 2. We don't have power yet, but need to power on the inverter. On the inverter, there's a toggle switch here with 3 positions, so it has to be in the down position. So basically, almost like it's off. I think that's to the switch. Middle, I believe, is off, and then up is constantly on. That's what it seems like. So, yeah. Now that it's there, you can see that we have power, and the light is on, so that our inverter power switch works. So, if I turn the power off, inverter light power off. Now if I turn it on, give it a second here, this fridge should turn back on once the inverter is ready to go. And again, yeah, we're down here in position number 2. Then we'll open her up here, and there we go. Refrigerator's working. All right, guys, so that's it with the switch. We've got the inverter light working. It's powered off the inverter right now, even though the generator is on, and it was a really simple installation without going into any wiring for the RV itself. I think it's gonna be safe. I think we're gonna have some success with the refrigerator, and it's gonna be much nicer going down the road without needing to turn on the generator or the AC, because we don't always need that. So this is great. If you got any questions, just let me know, and we'll see you next time.